Okay, so on the last one, I was having some audio problems. I apologize for that. So I'm not going to go with my microphone for my buds this time around. I'm just going to hope that the computer microphone is okay uh, to catch what's going on. So take a look at this guy right here. All right, so there's a couple things that are different than the one that we just did. All right. The mass, I think, is the same. The radius is the same. One thing that's different is that we've got a force that's a function of time. Another thing that's different is that that force is at an angle. Okay. So when we get ready to do our calculation, then we're going to have to take both those things into account. Our block is starting from rest in this case. Okay. It's going to move for 4 seconds. Either way around it, those are just details. Okay. We're still looking at a situation where what we have is that our delta H is going to be the integral of m dt. Okay. So we're still looking at that, which means in the end, to find F final, we're still going to be looking at that initial angular momentum plus my impulse here, just like that. Okay. So from that perspective, it's identical to the one that we just did. Okay. All we got to do is we got to adjust a little bit. And those adjustments come in defining what we're going to use for our moment. All right. So the moment is an FR. Okay. And we happen to have a moment that's a function of time. Or sorry, a force that's a function of time. So really what we're looking at here is 10t. All right. And it's actually dotted, or sorry, it's crossed in there. Crossed with our R. Okay. And that's a vector too. So what you can see there, they gave us a nice 3, 4, 5 triangle. Okay. So once we take into account that offset, all right, what we really need is we really need the 4/5 component. Okay. So our moment then really becomes 4/5 onto 10t and times our radius, which is 1.5. Still like that. Okay, compressing all that. Okay, we got 4 times 10, that's a 40. 40 divided by 5 is an 8. 8 times 1.5 is a 12. So we got 12t is what our moment turns into. Then to find that actual impulse value, okay, we've got our mdt, and that turns into the integral of 12t dt. Okay, so we take our antiderivative, we're going to end up with 6t squared from 0 to 4 because it's going for 4 seconds this time. All right, so 4 squared is 16. 16 times 6 is too much for me to try and do here on a Sunday afternoon. Brought to you by Nut Brown Ale. Maybe another reason not to do calculations in my head. 96. 96 is what I'm getting here. So this is 96. Okay. Once we have that, okay, we come up here and we do things just like we did before. We calculate. Of course, this time the initial angular momentum is 0, and we use our relationship where that final angular momentum is m, r final, v final, okay, and solve for the speed. That's all there is.